Hello everyone, welcome to another tutorial on basic electronics, and today we're going to build our first, I don't want to say real circuit because the circuits we've been building are real circuits, but let's call it the first circuit with a purpose, our nightlight. Okay, let's just get into it. 9 volt plus, and we have a diode. And we come off of this diode, and we go to our NPN, and then we have our resistor, and then we have our LED, and then of course we have ground. And this is an NPN, and of course this is C, this is E, this is B. And remember, our arrow is on the side of the emitter. So we have our little arrow there. I should probably draw this a little thinner. Down here we have our trim pot. And then we have another resistor here. Wow, that's a horrible resistor. But it is. It's a resistor. It'll work just fine, trust me. And we have a resistor here. And we go to ground. And let's put a circle around this. And so this is our LDR. So basically this is a 1N4007 diode. Any 1N4000 will do. This is our potentiometer, our 100K potentiometer, this guy right here. Now this is the A leg, this is the C leg, and this is the B leg. And B is not connected to anything. That's why it's just sitting here like this. I believe this is a 3904 is what we used in the lab. And I'm speaking past tense because I already shot the lab video. This is a 470 ohms resistor. And this resistor, you know what? Let's sorry, I know it doesn't make much of a difference, but that's just completely horrible. And this is a 22K resistor. So I think we covered, and this is, and we didn't have this. This is what the circuit called for, so this is what I'm going to tell you it is. A 1 million ohms dark LDR, light dependent resistor, or photocell. I keep hearing people call them photocells. I don't agree with that, but okay, so this is our circuit. Now we need to understand this circuit. What happens here when we turn this circuit on? I mean, it's one thing to see it in a schematic, and it's another thing to build it. But the most important thing we're concerned with is understanding this circuit. Because when you understand this circuit, and you'll see in our lab, we had to make adjustments on the fly. This didn't work as initially advertised. That we had to make some adjustments to it to get it to work with the parts that we had. So we need to understand this circuit. So what's going on here? We have our diode that makes sure the electricity, I almost called it current, but it's current and voltage. So it makes sure the electricity flows in one direction, which is actually, like I mentioned before, it's from negative to positive, but we're going to talk about it in this direction. So make sure it only flows in one direction, so that we can't reverse polarity. We don't have any capacitors in this, but still we don't want to burn out any of our components. So it's always good to put a diode in there. It also reduces the voltage usually by about half a volt. If you measure the voltage across this, you'll see a reduction of about half a volt. Okay, so then it comes to our NPN. Now, if there's no power here, then this guy is off. If there is power here, then this guy is on. It goes through the 470 ohms resistor and lights up the LED. So now we know this part of the circuit. This is our light, and this is the switch. And then this part of the circuit here, this is our control for the light. This is how we turn the light, and this is an automatic night light. So it's going to go off. It's going to come on when it's dark, and it's going to go off when it's light. So this is this portion here. Actually, it's not. I included the diode, but this portion here is the control for our switch. That's what we need to understand. This makes perfect sense. It's a switch. It's either on or it's off, and if it's on, the light is on, and if it's off, the light is off. This prevents the current from flowing. This is the one we need to understand. Okay, so how do we go about understanding this? Okay, here's our switch here, and we need plus volts for this to work. We need plus volts for this to come on. And I'm not going to get into voltage states and half voltage. Just say we need enough voltage for this to come on. You'll see in the lab that the LED slowly comes on. So this switch actually gets partially depressed depending on how much voltage is actually pushing against this. But we need voltage against here to turn it on. So what's happening here? We have, for all intents and purposes, we have an adjustable resistor. A potentiometer, and sometimes you'll see them like this. They'll have this with a little arrow here. I just didn't want to get this too confusing. For our potentiometer, here's our A leg, our C leg, and our B leg. And so what happens is electricity flows through here and can get pushed against this and open the switch. Right? So if we turn this on, if we didn't have this here, we would turn this on and our switch would come on and our LED would come on. Now we can adjust this from 0 to 100k ohms. So we can let the juice really flow, or we can trickle it in. Okay, so that's the first part of this. You can think of this, actually, in the lab we replace this with a regular resistor. We determine what the best setting is between 0 and 100k. We test it, and then we replace it with that resistor. And your results will vary at home, but you'll see in the lab. So basically, that's how our electricity gets here. And the higher this value, the less electricity that gets here to this leg to turn this on. Now the second part of this switch drains to ground. Now this is an LDR. What happens is, when it is sorry, phone just rang. What happens here is when this is dark, it allows the resistance goes up. So let's say at 1 million ohms dark. Let's say it's 10k in the light to 1 million ohms in the dark. So what happens is, when it's light, the electricity passing through here is also passing through here. So it's draining, so it's not putting any pressure on this NPN. And since it's not putting any pressure on the NPN, then the light is off. So basically, when it is light, more electricity is flowing to ground. So we never get a buildup of pressure here. When it is dark, there's a lot more resistance here. So the electricity builds up on this side and turns the switch on. And when it turns the switch on, the light comes on. So basically, in the dark, this is a high value resistor, so it's not allowing much electricity to drain. So this is also a variable resistor. I forget the exact one we use. I know we started off with a 500,000 ohms, 500 or 500,000 K or 500,000 ohms resistor, because I didn't have a 1 million ohms LDR, so we had to make adjustments. Now what we're doing with this, the reason why we have a trim pot here is because we're going to adjust the flow, the amount of electricity that comes in here, so that we can determine when our switch, how light or dark we want it to be before our switch goes off or comes on. Okay, so let's go back. Let's use our water analogy to understand this better. Okay, we have plus volts. This is our garden hose, and this is a tank. And then here's our ground. And here's our switch. So we have our trim pot here, which is this guy. We have our LDR here, which is this guy. So water flows in here. This is a pipe. We have a pipe here, and we can adjust the size of this pipe. We can adjust the size of this pipe, or we can adjust the pressure. I'm sorry, we're dealing with voltage, so we're adjusting the pressure. So here we can adjust the pressure from 0, which is let it all flow through, to 100 K, which is just let the water trickle in. Over here we could adjust the pressure too. Here we could adjust it from 10 K, which is let the maximum amount of water out, all the way over to 1 million ohms, which is only let a little trickle out. So what happens is the water starts to come in here. The water starts to come in and fill up. At the same time, it's trickling out the LDR to ground. So it's coming in here, plus volts, and it's trickling out to ground. Now, we adjust these things. This we adjust depending on the light, and this we can manually adjust. So we can allow more water to come in, and in here, depending on the light, if in a bright room we don't want this to come on, so we want the maximum water to flow. So basically, we're adjusting the valve, or the voltage pressure coming in here. So basically, and this is in theory, this may not be exactly what you see, but basically, if you have 10K here and 10K here, it's going to go through, and we're not going to build up any pressure in here. But as it gets darker, this increases. Let's say it increases to 500,000, 500 K ohms. Very little is coming through here. So because very little water is getting out, this starts to fill up. This tank starts to fill up in the dark. And once it reaches this level here, it then turns our switch on. This is the NPN. So it then turns our switch on. And when we go into the light, this value reduces again. This value here, reduces to, let's say, 10K, and the water drains. And it drains to the point where it's below the point where it turns on the switch, and the light goes off again. So as the water fills up, it turns on our switch and the light comes on. Because the darker the room, the tighter our valve, the more we close that valve, so less water can drain out. It's not an exact analogy, and the numbers, you may not get the same results if you use these exact numbers, but I'm just trying to use this to help you understand how this portion of our circuit is working. Now, of course, there's a valve here as well because we don't want to kill our NPN. So this resistor here is basically to protect our NPN. We don't want to dump 9 volts on the switch. But anyways, that's basically how it works. Voltage comes in through the trim pot and flows out through ground. And the smaller we make this, the more pressure that builds here. So on this end, we're adjusting the flow out. And on this end, we're adjusting the flow in. And the more we let in, the faster this is going to fill. And so when we adjust this, so by adjusting the 10K pot, we can determine how dark it needs to be before the light comes on, is basically what it is. So what you want to do is make sure it's on, blast it all the way to 100K. Put the pot to all the way to 100K. And then go into the room where you want the light to come on. Go into that room, make sure it's the darkness that you want, and then adjust this down. Maybe you'll wind up at 10, 13K before the light comes on. Because this guy has his resistance in the dark, so once you're in that dark room, so if you're in the light room and he's 10K, and you go into a fairly dark room, let's say it's not completely blacked out conditions, and he's at 100K now in this room, now you're going to adjust this down to allow more water to flow in here, to allow this until the light comes on. Once you see that the light comes on, you know that that's the perfect adjustment for the light to come on in that dark room. So if you measure it and it says, oh, okay, the light came on, you take your trim pot out and you measure it with your multimeter and it comes out to 10K, well, now you know what you can do is you can take a 10K resistor now and get rid of this, and this just becomes a 10K resistor connected to these three. Connected to this guy, connected to this guy, and then connected to power. And you'll see that in the lab. I think that just about does it. You may want to draw this out. You'll need it for making your lab. Okay, that's it. On with the lab. Hello, everyone. Welcome. And just have a sip. Okay, before we begin, there were some questions that were brought up in the earlier lecture, just prior to this, that I haven't done yet. I'll be doing it after this. I'm going to address some of the questions. Some of them I'm actually going to address here. But, let's see. Imagine a Sean, actually. Talked about kits and stuff and said I should have my own website and do kits. Wants to continue with the videos. And just to show him and you guys where we're going. And it's not our final destination, but a lot of the electronics projects we're going to build, most of the Arduinos are going to be original from me. A lot of the electronics projects are going to come from all my library of electronics books. This particular project here, I'll zoom in on it a little bit, is from Electronic Circuits for the Evil Genius. And we'll be building some of these. And don't be intimidated by this. It's actually very easy to build. You just take it step by step. And basically it's electronic dice. And I actually had it showing the binary too, because we're going to be doing binary. I'm going to teach you how to read binary, decimal, and hexadecimal, and translate between them. And so we're using integrated circuits on this board. As you can see, we got a bigger board. Eventually, you're going to need a bigger board. We start small. We start with the inexpensive multimeter. We the smaller proto board or breadboard, and then we start to move up. We'll move up in our multimeter. I'll still use the old one for the tutorials because it's my understanding there's a lot of people who can't afford the more expensive electronic stuff. So we'll use the less expensive stuff. But this is just an example of some of the things we'll do. And we're actually going to do this on the microcontroller too, which is much easier, but involves programming. But I'm going to take you guys step by step through all that stuff. Okay, let's put this aside. So we're going to do many electronics projects together. We're going to do microcontrolling and programming. We're going to make things wireless. We'll have wireless communications between these things. You'll notice some of the parts are a little different, and I apologize for the whiteboard that I'm working on, but I'm at home today. It's a Sunday, and I decided to make this tutorial, hence the music in the background. You could probably see my little Chumby in the edge here. But I do have some parts here, and I decided to just, since I got behind for the holidays, to actually make this nightlight tutorial. Okay. So I will go over the parts list, or I have gone over the parts list. It's a time thing. When I create the lecture just prior to this video. And I go over the parts, and one of the things I discuss is you need an NPN. Well, I wanted to introduce you to a couple of different NPNs. Now, our initial introduction to the NPN world, let me zoom in. Our initial introduction to the NPN world just had one NPN, and if you remember, it was Enjoy Baked Cookies. If you had the flat side facing you, and from left to right, it would be EBC. Well, that's not the case for all NPNs. As well as someone mentioned about, they were wondering how I didn't show the NPN as amplification. We'll actually get to that. And as you can see, there's an array of NPNs here, depending on what you want to power, how much, like these tiny little NPNs here. This probably do a couple of LEDs, that's all. But something like this, you could do a lot more. But you also have to pay attention to the data sheets. This is an NPN, and actually the data sheet for this is right on the back. And on my monitor, this looks backwards, so I'm hoping it's not backwards for you guys. You'll notice down here, it's actually BCE. So you really need to pay attention to these data sheets. But it'll also give me my my maximum voltage for each of these, my amperage. So it's basically a little data sheet of what I can do with this. Now you'll also notice this little piece of metal on top with this little hole. What that is that is a heat sink. And was it Jerry? Let me see. I think it was Jerry. Yeah, Jerry's trying to fix a stereo. And we were talking about PNPs and NPNs. And he's actually replaced, the first part he replaced was a PNP, and I think now he's replacing an NPN. And he has some of this stuff here, and I mean to talk to him in more detail. But right now, just so you guys know, if you're working with an existing board, like he's got a stereo receiver that he's working with, and you run into something like this, and usually you'll see a screw here, and it's screwed to a piece of metal. And if there's anything in between these two pieces of metal, don't touch it. Not with your bare hands. Put on some plastic gloves or something like that, because what it is, it's called thermal paste. I'll show you. I'm actually building a PC in my off hours, and I'll do a little video, and I'll show you the thermal paste. It's really toxic stuff. Leave it alone. But if you run into some paste that you see on the connectors where they're soldered in, that is not thermal paste. What that is flux, and it helps the solder adhere to the components and to the integrated circuit. So pay attention. There's all different kinds of NPNs and PNPs. We're going to go through them. We're going to build a functioning motor using the microcontroller to control through an N-channel MOSFET. So we can have larger motors, so the microcontroller, which has very little power, can power something much more powerful. Although the op amps we'll get into op amps as well. But yes, you can use NPNs and PNPs for amplification. You use a little bit of current. Of course, the B is to the left on this one, so you use a little bit of current on the B, and a lot more current between these two, so you actually amplify, and we'll actually build some amplification circuits. But we're not doing that today. Today we're building a nightlight. Today we're using this purely as a switch. Okay, so we have some components here. We have our diode. Let me see if I can read this one. 1N4007. So this is a 1N4007 diode, power diode. I haven't decided which NPN we'll use. It's one of these two. One is a little more powerful than the other. Since it's a little nightlight, I think I'll just use the little NPN. And both of these are the same. I looked up the data sheets. It's Enjoy Baked Cookies, EBC. We have a couple of resistors. We have a 22K and a 470 ohms resistor. And we need an LDR, a photocell. Now, once again, you remember me talking about NPNs and PNPs as how fast things switch? Here's a whole series of LDR photocells. Now, you could use these to turn things off and on for light, but they're very slow to switch, to change their resistance. They're fast compared to what we can see, but they're slow. They're actually phototransistors, infrared transistors. They take light sources and they switch, and those are much faster switching. And we'll actually get into that when we start to send data over laser pointers and stuff like that. But today we're going to be using one of these, and it requires for a 1 million. This circuit requires a 1 million ohms dark. Now, because we can adjust, it doesn't actually have to be exactly a 1 million ohms dark, but we're going to test some of these. Now, before I get into testing, unfortunately, I have a auto-ranging multimeter here at home. If you can afford to go up from the original multimeter, which is the manual ranging multimeter, to this, it's much better, especially if you're going to start testing a whole series of resistors. Say you've got a ton of resistors sitting in some tray, and you want to see what they all are, and even if you've gotten to the point where you're no longer counting on your fingers to determine the resistance, and you can tell by the colors, it still takes a while, and you want to make sure, because some of these colors are hard to tell. It's hard to tell blue from violet sometimes, so you may want to test each one of them. And if you have an auto-ranging multimeter, it's a lot easier. I also wanted to mention, in one of my earlier tutorials, and Matthew Peters called me on this, what I said is we were testing ohms, and if you weren't sure the part you were testing to start at the low range and go high for the ohms, the reason why I did that is because if you start at the high range and go low, you may see like 0.002 for a 220 ohms resistor and not know exactly what it is. But as Matthew Peters pointed out, you're supposed to start at the high range and go low so you don't burn out your multimeter, especially when you're dealing with voltage, current, all that stuff. I've never burnt out a multimeter testing the ohms of these quarter watt resistors the opposite direction, which is probably why I did it. But he's right. You shouldn't do that. You shouldn't get into these bad habits. And like I mentioned, these aren't scripted. There's mistakes. And I thank you guys for calling me on them when you catch them. And I will correct them. Now, if you have an auto-ranging multimeter, that you don't need to worry about that. You don't need to be concerned about that. Because what you'll do is, and since we have it here, let's go through this auto ranging multimeter. So as you can see, there's the it's an X-Tech. I don't actually see what the model is, but anyways, it's an X-Tech, and here we have, you'll notice, ohms, capacitance, continuity testing. It's like a whole bunch of stuff on this one button. We've got volts AC, volts DC, hertz, Fahrenheit and Celsius for temperature sensing. We've got amps, milliamps, microamps for testing current. You know, we can choose between the different modes. And if, so let's go to ohms. We're at ohms right now. And up here you'll see it's reading million ohms because, you know, we're not testing anything. If I put my fingers on it here, it's 2.3 million ohms. You know, because my skin conducts electricity, but it has this great resistance. And that's one of the devices they use for lie detectors. As you begin to sweat more, your resistance goes down. And you'll actually see a project where I have a plant that automatically waters itself, or we could water it through the internet. Its water sensor is basically based on this principle. It's just two connectors and how much voltage passes through them. When you first water the plant, more low voltage current actually passes through it. Okay, so this is the auto ranging multimeter. It's pretty simple, straightforward. You don't have to worry about starting high and going low, which is what you should do. Matthew was correct. Another thing, I need a battery for this circuit. And I've got 3 9-volt batteries here, and I need to know if any of these batteries are good. And this also brings me to Larry, I'm not even going to butcher your last name, his question about power across the switch. When Larry was testing the last circuit we built, he noticed that even when he wasn't pressing the switch, he was testing across it, he could see the voltage across it, but the LED wasn't coming on. So this confused him, which, you know, it would confuse all of us. But just like this battery, see, there's no switch here, but if I put the red on the positive and the black on the negative, I'm going to see some voltage on my multimeter. So what happens is you're testing the potential voltage across the switch. So there's no switch here, you can see. You know, I'm going one lead on one end, one lead on the other. So it's the same thing for the switch on the breadboard, and the next time we'll actually put a switch, not on this particular one, but and I'll show you exactly what I mean. So it's the same as testing this battery. There's no switch between it, but yet when I put on either end, I can get a voltage reading. And I'm getting 6.77 volts, which tells me this 9-volt battery doesn't have much, if any, juice in it whatsoever. So we'll hold on to that battery. Now let's take the next one. And let me put this up. See if I can have this. I don't know if you guys can see that at home, but once again, positive, negative. If I didn't know, or if it wasn't marked and I put it on wrong, it would give me negative. I have negative 8.02 volts, which is still not strong for a 9-volt battery. Let me put it on the right way. It'll read the same. It'll just be positive 8.2 volts. Of course, let me put it on the right way. Positive 8.2 volts. Still not very strong for a 9-volt battery. I don't know if I'm going to have a 9-volt battery today. I've got a couple of hacked power supplies that I can use. Let me see this one. This one's 8.93. So this one has a little more left in it. And I remember when I was younger, the way I would test 9-volt batteries is I'd touch it to my tongue, and you'd feel a little, I don't want to call it a shock, because it really wasn't shock. You'd feel a little current going through your wet tongue, because your wet tongue is actually less resistant because of the moisture in your mouth. And if I knew that these things were clean, I'd just put it on my tongue and you could see it. If I went over to ohms again. And see, I'm at ohms, and I also don't want to rust out my leads or anything. But I could stick this in water and you'd see the ohms. Right now I'm holding it in my hand. 1.9, 2, 2.1, 2.2. The resistance is slowly going up. Okay, enough chatter. Oh my God. I'll address more of these things and more of these questions at the end of this video. But let's get to building here. Okay, so we have our parts. We have one N4007 diode. We have one resistor. Now I could read this, but let's actually use our auto ranging multimeter. Volt DC. And if you went out and bought the manual one for 12 bucks, that's okay. We're still going to use it. I'm just not using it today. And let's zoom in. Should zoom in for this. Okay, so this one reads DC. So we're in ohms. This is it says 0.463K. Well, that's 463 ohms, 0.643K. So you got to pay attention with these auto-ranging multimeters as well, because it's not giving me 470 ohms or 463 ohms. It's giving me 0.463K. And on the manual ranging, if we put it on 2K, the manual ranging multimeter, if you put it on 2K, you'll still see 0.463 ohms, which is 463 ohms. So this one is our 470 ohms resistor, plus or minus 5%. And so we can guess what this one is. This one should be our 22K. Yep, 22.3K. 22K. That's our 22K resistor. This is our 10K potentiometer. Sorry, I don't know if I showed you that. I think I was off camera, but the multimeter was on camera. Now what I did last night was I just soldered a couple of wires on here. Now you got to notice, this is solid core. I always try to buy the solid core wire. It's just much easier to work with. And I hooked up here to my potentiometer. And let me see if I can quickly find some alligator clips. And then again, this is okay, here's one alligator clip. Let's get a black alligator clip. Black and red. Like I said, we can use any color we want, but we're going to use black and red for this. Okay, so I'm going to take one end, clip it to the black, another end, clip it to the red. Remember, these are ACB, or in this one you'll actually see 1, 2, 3, but it's ACB. And we're connecting to AC, that's where we get the variable resistance. And AC, AB is where we'd get the full resistance of it. And CB is we'd also get the opposite variable resistance. Okay, so now let's hook this up to our multimeter leads. So you see I'm hooking it up to the... So we have our trim pot now is hooked up, and our initial reading is nothing. Hopefully we've got good solder points. We've got good connections to the wire, good connections to our leads. 91.4K. So that's pretty much almost to the max of 100K. I can't turn it up anymore. I can turn it down. As you can see, it's going down. 53K, 34K, 21K, 29 ohms, and 1.2 ohms, which is pretty much off. So when we're working with our circuits, just like how Matt mentioned that we want to start at the highest range and go down, so that we don't burn anything out, generally we want to start at the highest range. Now, are we going to burn something out in this circuit if we start at the low range? No, not in this circuit. But later on, I'm going to show you how you use your potentiometer to experiment with some of the LEDs and stuff like that. So we're going to make sure it's at its highest rating, which is right now, it's 100K trim pot. As you can see on the top here, it says 100K. B100K. It depends on your potentiometer. But because of the variance, the max I'm getting is 91.4K. Good enough for our purposes.